Hi everyone, welcome back. In previous video we have learned how to calibrate our camera based on the images we have captured, which is including the ChArUco boards. And in this video we are gonna learn how to use these output parameters in our camera anymore. So the video results, the frames are gonna be coming calibrated frames after using these parameters, these output parameters. So this is important. And mostly the camera matrix and distortion coefficients are gonna be enough. The rotation vectors and the translation vectors, which is also an output of this calibrate camera ChArUco function, these are needed in the case of if you are doing some kind of stereo vision kind of purposes, jobs, tasks. So in those cases you are gonna need these vectors. So for our case, just we want to remove the distortion of our camera matrix and distortion coefficients are gonna be enough. And once if you want to calibrate, mostly you need to save your results into a file. This can be a MPZ file, XML or YAML. So these kind of files you can save because you don't need to always calibrate your camera again and again. You can calibrate, you can save the results, and you can use those parameters anymore. So we are gonna do the same. First of all, to show you, we can again use the file storage of OpenCV, which is very useful. And here we can call a pet, which is I can give this pet, and also I can write something like camera matrix dot YAML, and here we need to also define we want to file storage but write, the purpose is write. Okay, once this is done, all we need to do is just calling fs again. Oops. And after that we can put a name, maybe camera matrix, and after that we can put the camera matrix, and this is written into the file by this. And also I want to get distortion coefficients, which is also similarly distortion coefficients, and this is gonna be this one. So now we have written our file and we need to release it. Okay, and it's done. Once this is done, I want to test my camera. I don't want to switch to a new code, so what I can do is just create a new function, which is just test camera, and this is gonna take even it doesn't need to take, I can manually enter my file path, it's not really important. So once this is done, I want to call my test camera. Okay, this is enough. So I don't need, yeah, it's better to give the path again. Okay, just define a path into here, which is gonna be the path, calibration path. And here we can define recursively again by reversing again camera matrix and distortion coefficients. This is needed. And here we can call again our file storage for the purpose of this time is reading, which is just give pet this time, and calling file storage, and this time read. Okay, now we are reading. So we can just basically this OpenCV file storage class is very useful. I like it. I also suggest you, instead of standard libraries, camera matrix, and here we can make the opposite operation, which is camera matrix. So it will assign it into there. Similarly, I don't want to write, okay, distortion coefficients. And so I got my parameters back now by reading this file. Let's release again. And once this is done, I can create my video capture. So if your camera is also called by this, you can call accordingly. So after that I can create a frame to check my new calibrated frames, but yeah, I want to compare it before and after. So frame before, frame after. So I want to see how it looks like, and after that I can also define some named windows to be able to resize easily. Before, which is 0, is window normal, and after. So I just need to give the same name to imshows, and that's all. Let's make a while loop. It can be forever, doesn't matter, I can stop it. So here we can get our frames from the capture, from the camera. Oops. Yeah, of course I didn't define. And a frame, this can be frame before, so I can directly show it. Okay, this is before and frame before. Okay, so once this is done, all I need to do is call a magic full function, which is undistort. So in here we need to give the source, which is frame before, and frame after. Oops. Frame before, frame after, and camera matrix, which we have, and distortion coefficients. Okay, and this is also done. The next all we need to do is just show, right? Nothing else. So here we need to careful about after and frame after. And now this frame after is the one which is an undistorted frame, which is a calibrated result, I can say. So just say wait, k1 is okay. Yeah, it is done. Let's see how it looks like. First of all, again it will calibrate, but you don't have to calibrate again and again. Just do this in a separated code and get your file, which is YAML. Okay, you see it's trouble. Yeah, why this is very bad? It's good example also because this is bad because my in the previous video which I have talked, my calibration, my captured ChArUco boards are trouble. So that's why this is trouble. The explanation is like that. And okay, what else I want to tell? Yeah, in this YAML, which is including the distortion coefficient and the camera matrix, you can also add the rotation and the translation vectors, which is good, but if your purpose is your case is needing those parameters, otherwise you don't need to save it. Yeah, my example is a bad example. It's okay because we should see also, because my collections are trouble. You see my image is big. I use a very small ChArUco board and also not very well tilted in all the images. Yeah, but yeah, at least we see how we are using those parameters, those camera calibration result parameters, and also we have learned how to calibrate our camera. And I'm done for this video. Thanks for watching. See you in the next videos.